This is Euclid Book 10, proposition number 80. Sorry about the brief pause. Wanted to make sure you got everything. To a first apotome of a medial straight line, only one medial straight line can be annexed, which is commensurable with the whole in square only, and which contains with the whole a rational rectangle. For let AB be a first apotome. Okay, AB is a first apotome of a medial straight line. And let BC be annexed to AB. BC is going to be annexed to AB. Therefore, AC, CB are medial. Okay. AC and CB are medial. And they are only commensurable in square, such that the rectangle ACCB, that's this one right here, which they contain is rational. Okay, that's by Euclid Book 10, proposition number 74. I say that no other medial straight line can be annexed to AB, which is commensurable with the whole in square only, and which contains the whole a rational area. For if possible, let DB be so annexed. So now we're going to add DB to this whole thing. Therefore, ADDB, that's this rectangle right here. Okay. Now, hold on. Therefore, the line AD and the line DB, both of those lines are medial straight lines, and they're commensurable in square only, such that the rectangle ADDB, which they contain, is rational. So this area is rational. This is by Euclid Book 10, proposition number 74. Now, since the excess of the square is ADDB, what does that mean? We're going to add these two areas together. Okay? That sum is actually going to be greater than twice of this area right here. Okay? Now, if we subtract twice of this area from the sum of these two areas right here, whatever total we get, okay, is going to be exactly the same as the following. Okay, so first thing we got to do to find out what it's the same to is we've got to then add these two areas together. We got to add these two together. And then we have to subtract twice the area of this from this sum. Okay? So, let me recap. If we subtract twice the area of this from the sum of this, okay? We subtract twice the area of this from this sum, whatever number we get, which we're going to call x, okay? It's going to be the same amount, okay, that we're going to subtract twice the area of this from this, and we'll still get x. That's what we're saying. I know, that's pretty complicated. Okay, so what is x? Okay, well, we told you what x is, but we also need to tell you that x happens to be the area of this. This is by Euclid Book 2, proposition number 7. Therefore, alternately, the excess of the squares on ADDB. Okay? We add these two together over the squares on ACCB. Okay. So, the sum of these two squares is actually going to be bigger than the sum of these two squares here. So, what we're going to do is we're going to say this plus this is bigger than this plus this. How much bigger is this sum than this sum? We're going to call it x. Okay? So x will represent the difference of this whole area and this whole area. So if we add these two together, okay, you're not seeing this. I know you're not. It's hard to see this. Okay. So we're going to say that the sum of these two is going to be a. And now we're going to say that the sum of these two is going to be B. There you go. Does that make it a little clearer for you? This sum is A, this sum is B, and A minus B is going to be X. Okay. Hopefully that cleared it up for you. Okay, so now let's say that this area is A, and this, no, whoa. Back up. Twice of this area is A, and twice of this area is going to be B. So if we subtract twice of this, if we subtract twice of this area from twice of this area, we get X. And we already said that X was also the sum of these two minus the sum of these two. That's where we get all this from. Wow. Now, so X is going to end up being a rational area. Therefore, this area here is going to exceed this area here. Remember we said that this plus this is A, and this plus this is B. Now we're going to say that this exceeds this by a rational area, which is impossible for both are medial. Okay, this is by Euclid Book 10, Euclid Book 15, Euclid Book 10, Proposition number 15, and Euclid Book 10, Proposition number 23, Porism. And a medial area does not exceed a medial area by a rational area, which is by Euclid Book 10, Proposition number 26. The end. Wow. I know I learned a lot. I hope you did too. Alright. I will tell you more in a future video, so I want you to stay tuned.